Good morning, good afternoon, and good evening, everyone, and thanks for joining us today for Bluestoberfest. Fall has arrived, and we're entering a season of reflection and celebration. For us at Blues, it's a good time to look back on where we and the industry have come over the last year and share with you some of the exciting things that we've been working on to help you make your IoT aspirations real. For the next 45 minutes, we're going to spend some time recapping some exciting new and recently released hardware, demonstrate a feature that makes performing firmware updates easier than ever, and share some Notehub enhancements that you'll want to incorporate into your next project. I'm joined by Rob Lauer, TJ Van Tol, and Zach Fields, and they can't wait to share with you what we've been working on. But first, let's talk about where we are as an industry. And if you've been around this IoT space for a while, you've surely heard some of the wild prognostication for IoT device growth that's been meted out over the last decade. Like in 2011 when Cisco predicted 50 billion IoT devices by the year 2020, or when SoftBank CEO Masayoshi Son upped the ante in 2016 and boldly predicted a Cambrian explosion of 1 trillion devices in the next 20 years. Reality, however, has fallen far short of expectations, and instead of 50 billion devices in 2020, we got 11 billion. Still a lot, and still growing, I'll note, but slower growth than anticipated. And slow seems to be a theme of the recent IoT, with projects taking anywhere from 2 to 5 years to reach the finish line, and 75% of projects taking twice as long as planned. And why are we moving so slow? Is it because hardware is hard? Because our space is inherently complex? Because there are many more moving pieces to a project that includes atoms instead of just bits and bytes? All of these things and more are true. Now, we started Blues with the express purpose of finding and eliminating complexity in the IoT space, of looking for ways to accelerate developers by removing roadblocks, unnecessary constraints, and the inertia that dominates the space. We launched the Notecard and Notehub.io in January of 2021 in an effort to simplify cellular connectivity. The Notecard is a no-fees, data and service included device with coverage in 139 countries, no subscriptions needed to use the cloud service. In the cloud service, Notehub receives data as a proxy from the Notecard so that you can route your data to your cloud app of choice, while also managing fleets of devices, device state, and update firmware over the air. Notehub is all about securely transmitting data both from the Notecard and to your cloud. And by secure, I mean that data is transferred off the public internet via private VPN tunnels and can optionally be encrypted. There's no certificate management or key rotation required. The Notecard knows exactly where to go as soon as it is turned on. And rather than forcing you to learn yet another dialect of AT commands specific to our modem, the Notecard speaks 100% JSON. Everything from adding your sensor data to syncing to the cloud is possible via a JSON-based API. And rather than selling you a piece of hardware that is more than you want or leading you down to add yet another SaaS platform to your stack, the Notecard and Notehub operate as a thin device-to-cloud data pump, middleware that takes the complexity out of secure, low-power cellular and Wi-Fi so that you can focus on your sensors, your MCUs, your programming language of choice, and route your data to your cloud service, no matter where that is. And in 2022, we've continued our commitment to simplifying and speeding up IoT adoption with new hardware, firmware capabilities, and the cloud. On the hardware side, TJ is going to share some hardware, both new and coming soon, including Sparrow, a developer toolkit for building LoRa-based device cluster applications, while using the Notecard and Notehub for cloud backhaul. We launched Sparrow just a few months ago, and as a complete toolkit, it includes not only hardware, but also sample firmware and a complete open source reference web app for viewing and managing your LoRa-based applications. Next, Zach is going to jump on and talk about a feature that we've just released in beta called Outboard DFU. And when we say outboard, we mean like an outboard motor on a boat. Because in 2022, the state-of-the-art for performing over-the-air device firmware updates, or OTA DFU, requires developers to either yield complete control of the DFU process to a platform provider and accept their constraints, or rely on a cloud service to host and deliver firmware binaries, but manually perform the in-place firmware upgrades with code littered alongside a running application. Outboard DFU, which you'll see more about in a moment, is something different. It's an approach that leverages the Notehub for binary hosting and Notecard for firmware delivery, but which allows the Notecard to take control of your MCU, opt in of course, and lay down any firmware you wish. So you can ship updates to brick devices, update parts of a binary, like an ML model, or transition completely from Arduino to Zephyr, CircuitPython, and back again. Finally, Notehub, the cloud piece of our device-to-cloud data pump. Now, we, like you, tend to get starry-eyed about hardware around here, but we have some exciting new features and improvements around Notehub to share that make it easier than ever to manage devices and route data to your cloud applications. So, without further ado, let's get started. Over to you, TJ.
Awesome. Thanks, Brandon. And let's just dive right in because it's Bluestoberfest and I have lots of cool things to show you. We're going to start with Sparrow, which is our new LoRa-based product that we released back in August. Then I'm going to introduce you to two new note carriers, one of which is already in our shop and one of which is coming soon. And then we're going to wrap up by looking at a new version of our Swan microcontroller. So lots of cool stuff to do today, but let's open up by talking about Sparrow. Now, Sparrow is our way of allowing you to easily build just LoRa-based device clusters that can communicate with the cloud. The architecture looks a little something like this, and the idea is that you can set up a series of sensor nodes, so things that are measuring temperature, humidity, whatever the case may be, and have those nodes communicate with LoRa, the LoRa protocol, to a gateway. That gateway, in turn, then knows how to receive that sensor data and then send it up to the cloud over Wi-Fi or cellular using the Notecard. The idea here, the sort of overarching reason of doing all of this, is that this architecture allows you to add cloud connectivity to this local series of devices while keeping the per device costs as low as possible. Now, the way you can set this up with Sparrow is by getting a Sparrow developer kit, which we have available on our shop, shop.blues.io, for $199. The kit comes with everything you need to set up one gateway and two sensor nodes, and those sensor nodes know how to measure temperature, humidity, pressure, and also motion through a PIR motion sensor out of the box. All the firmware for Sparrow is open source, so you can modify that firmware. There's ways of adding your own sensors, customizing these nodes to measure or do whatever you'd like. And then we also offer an open source reference web application, as well as documentation on how to set up an app like this for yourself. So if you want to build your own dashboard for viewing your sensor data, for managing it, we can help you walk through that as well. Now, just to pause for a second, I know I just threw a lot at you. There's a lot going on, but I think this is a lot easier to understand in action. So I want to swap over and show you a quick demo. And to do that, I'm going to start by switching to my camera on my desk so we can look at some of the hardware. All right, so what you're looking at is the Sparrow Developer Kit unboxed. The kit comes with a Notecarrier-A and a Wi-Fi note card, as well as what we call a Sparrow Essentials board, which is connected to the note carrier through this included quick cable. The idea here is that the Wi-Fi note card is providing the network communication, so we're going to be sending our data over a Wi-Fi connection. I could easily swap in a cellular note card if I'd like here, if I wanted my gateway to operate over cellular. And the Essentials board is doing the LoRa-based communication to any sensor nodes that I have in my system. But together, this is operating as the gateway in our architecture. The gateway accepts data from sensor nodes, and you'll see that we have the two included sensor nodes over here, both in their enclosures. One I have facing up, so you can see the motion sensor, and one I have on its back with the back off, so you can see the inside of the enclosure. You'll see that the nodes can easily be charged with two included AAA batteries. And they both have, in addition to this motion sensor on the front, they both also have temperature, humidity, and pressure sensors in them as well. And once you have everything hooked up, you have everything connected, you have the batteries in and whatnot, you actually only need to do two things to get your network up and running. The first is you need to pair the gateway to each of your sensor nodes, which you can do by hitting the pair buttons on each. It's located here and here. The process works a whole lot like Bluetooth. There's LED lights that confirm that this process was successful on each. And once paired, the second thing you have to do is configure the Notecard so that it knows where to send the data to, and specifically which Notehub backend to send your data. You can find that information as I switch over to my browser, as well as really full instructions on everything Sparrow on the Sparrow Quick Start, which is available on dev.blues.io, which is our documentation hub for all things Blues, in the Quick Start menu and the Sparrow Quick Start. Now, if you have a new dev kit, I'd recommend going through this entire guide. It walks through a lot of what I showed you. But just to quickly point out, the specific bits in setting up the Notecard are in this section down here. And basically, you just need to run a hub.set command to associate your Notecard with a given backend. And then you also need to run a card.wifi request. So if you are using a Wi-Fi Notecard, so that it knows what network to send your data over. The cool thing is, though, once you have that set up, you'll start to immediately see data flowing into Notehub from your sensor nodes. So if I switch over to my Notehub project, you can see readings that have been coming in from my house throughout the day. This last batch is actually the motion sensor triggering. As I was pointing out everything on my desk view, I apparently triggered the motion sensor a whole lot. But if I scroll down, you can see some temperature, pressure, humidity readings, voltage readings that have been coming in throughout the day, signal strength, and stuff that is coming through as well. So I'm getting data from throughout my house, which is really cool, but I want to do something more with this. So the next thing to check out on our documentation is if you go back to just the dev.blues homepage and go to the Sparrow section, you'll see that we have a guide on what to do with your Sparrow data. So whether you want to take the data and route it to your own backend, maybe you just want that in your own database, you want that in your own server, whatever the case may be, we can help you do that. Or if you want to use your data through our reference web application, we have a section on helping you set that up as well. The Sparrow reference web app is an open source project, so you'll see that it is up on GitHub, and we have full documentation on all the steps you need to do to set this up and get it running yourself. And if you want to see what this reference web app looks like in action, there's a link here to an official demo that we have that has data that's coming actually from my house, the nodes I have set up in my house, as well as my coworker page as well. So you can check this out. This is Paige's gateway, and then mine in Michigan here is as well. And we can see here in my office, if you're really curious what the temperature, humidity, motion that's been coming from my office, you can check that out as well. It's totally public, so if you're looking for something to multitask during this webinar, you can check it out. And the last thing I'll mention on Sparrow is our builder's guide, which is in the same navigation structure, but down here. This guide has steps on how you can use the Sparrow firmware, which is also open source and available on GitHub. And you can move beyond the basics of temperature, pressure, humidity, and motion, and start to introduce your own sensors with your own behavior. All right, so that was Sparrow, which I think is a really cool product, especially if you have any sort of project that has a cluster of sensors that you need to put in a location. Sparrow works really, really well for those types of situations. But we do have a couple other pieces of hardware to look at and that I want to introduce you to today. And the first of those is the Notecarrier-B. If you haven't used the Notecarrier-B before, it's our small form factor note carrier that's essentially the smallest and cheapest way that you can just plug in a note card and get up and running quickly. The Notecarrier-B is a product that we've had before, but we're releasing a new version of this within the next couple of days, probably sometime next week, that has a couple of additional new features. Most notably, there is a new JST connector for LiPo battery support, which, by the way, these images, this is the top of the Notecarrier-B and this is the bottom. The second new thing is a new quick I2C connector that's going to be on the bottom over here, as well as a dip switch for switching between passive and active GPS, just for giving you a little bit more control for how you want GPS to work when you're using it alongside the B, which, by the way, I think the B is really excellent for asset tracking, simple asset tracking types of projects, just because the note carrier itself is so small, it makes it really easy to plug in a cellular note card, plug in a LiPo battery, plug in an antenna, and you just have an asset tracker that you can take around for pretty cheap and easy. It's really, really cool to use. So that's the new Notecarrier-B, which again isn't in our shop quite yet, but will be be in the next handful of days or so, so keep an eye out for that. But our other new note carrier that is in our shop already, and as well as in my hand here, is the Notecarrier-F. The F in the Notecarrier-F is for feather, as its main feature are these Adafruit feather compatible header sockets on the top of the board. And the main idea here is the F is a development board that makes it super easy to use a microcontroller, a feather compatible microcontroller, alongside the note card, as well as adding some developer conveniences. Now the F is an upgrade from the Notecarrier-AF, which some of you might be familiar with, but the F has a number of improvements, such as a new form factor. So if I hold up the F against the AF that I also have available here, you can see the AF is just smaller, it's more rectangular. I think it fits a lot of different enclosures and such better as well. The F also is more power efficient to the tune of 15 microamps when idle. It has a new V+ JST connector, which is on the top of the board over here, which just makes it easy to power the board from a non-rechargeable power supply, or really just any power supply that you want isolated from the charging circuitry. It has two new quick connectors, which are on the image over here on the right hand side. It has pin labels, just labels for what these pins are, on both the front and the back of the board, which is one of those small things which is surprisingly convenient when you use the board over time. And finally, the F has no onboard antenna. Now this is interesting because what we found is that most of you that are using the note carriers have your own antenna that you are using, so we didn't want to just build one in. And for those of you that don't, no worries either. In our shop, alongside the Notecarrier-F, when you purchase it, you can also include a Molex dual band antenna, which I have one of these here, that provides both LTE and GPS. Really easy to hook in. I've been using this one for a handful of months, and it's been working really, really well. And really just overall, the F is just a really useful new note carrier. And if I can tell you a secret, this is actually my personal favorite way to build with a note card, just because I find the F to be just a really elegant package of just putting the note card in the MCU in one place, easy to plug an antenna, easy to plug in a battery, build something really, really cool that works over cellular, and just a lot of fun to work with. So this one is in our shop and you can check it out today, and I highly recommend it because, like I said, it's super, super useful. And I did mention that the Notecarrier-F can work alongside any feather compatible microcontroller, but some of you might know that we make our own MCU here at Blues, and that is the Swan. And the last thing I want to cover today is a new version of the Swan, version 3.0. If you're unfamiliar with the Swan, it's a feather compatible dev board with an STM32L4 chip with 640K of RAM and 2 megs of flash. It supports C, C++, Arduino, and CircuitPython, so there's lots of different languages you can program with on the Swan. And with the 3.0 release, we've added a handful of new features. First of all, there is a new quick connector on the top of the board. There's some pin updates that we made to better conform with the feather specification. And most importantly, we've added support for a brand new feature that we're announcing today called Outboard DFU, which you're actually going to hear about in quite a bit of detail here in just a minute from Zach. So the Swan 3.0, it isn't available in our shop quite yet. It will be in the next handful of days, definitely by next week. So you want to keep an eye out for this one as well, especially if you want to experiment with Outboard DFU at all. And there you have it. Between Sparrow, the Notecarrier-B, the Notecarrier-F, and a new Swan, we have lots of new hardware for you to experiment with. It is Bluestoberfest after all. But our fun is just getting started. I teased Outboard DFU a little bit, and I know you're excited to see it in action. So I'm going to toss things over to Zach, who's going to show you a nice demo of that. So Zach, why don't you take it from here?
Thanks, TJ. Happy Bluestoberfest, everybody. My name is Zach, and I'm here to tell you about our brand new feature, Outboard DFU. But before we can really talk about why that's so amazing, we need to understand what DFU looks like now. So let me switch over to my desktop and let's have a look. So here you go. What? Like, oh, but Zach, it's so small I can't see the code. I know! You should never see this code. This is only code to facilitate DFU. Like all of it. There's so much code here. So I guess that's enough for now. Let's take a look at what Outboard DFU looks like and see if we like that better. Let me switch over to that code. Just 1 second. Oh yeah, that's what I'm talking about right there. This is only the lines of code from your program and nothing to do with handling over-the-air firmware updates. How is this even possible? Well, the way that this works is because the note card is working as a programmer. It's working with the MCU, pulling the strapping pins, and loading the program onto it directly. That's how we can get away from having all of the code to manage swapping of memory littering up the code that we really just want to work on, like what you see right here. So before we talk about it too much, let me pull up a couple illustrations so I can describe this a little bit better. Okay, here's an example of the Swan's memory laid out with CircuitPython. You can see at the lowest memory we have the UF2 bootloader. This would allow you to drag and drop files from your development machine directly onto the Swan, specifically CircuitPython scripts. Right behind that in memory we can see we have the CircuitPython runtime. Obviously this executes the script and binds it down to the board. And then all the way at the back, the green page there, that would be your actual CircuitPython script. So now that you've got this idea in your mind of what the memory looks like, I can describe a little bit better to you the way that Outboard DFU works. Unlike traditional DFU that forces you to dedicate half of your system's memory to the new image while it executes the old image in the other half of the memory so they can perform a swap, Outboard DFU allows you to perform a targeted deployment. That's because Outboard DFU writes a page of memory at a time because it acts as a programmer. So it really shines in the world of CircuitPython like we can see here. Instead of me having to get rid of enormous amounts of memory to replace the UF2 bootloader, to replace the CircuitPython runtime, and then finally to replace the script, I can just start and end by replacing the script. Or conversely, if there was a new CircuitPython runtime that came along and it had maybe some bugs eliminated or whatever, I can leave my script up there, I can leave the bootloader on, and I can just replace the runtime. But why stop there? Instead of just replacing the runtime, why don't I just take it to the next level and replace the entire paradigm? That's right. We can compile an Arduino binary and then use a targeted deployment to replace the UF2 bootloader. And then instead of having a CircuitPython application running, we will have an Arduino application running on the bare metal. This can be really important because there are things you can do in Arduino that you simply cannot do in CircuitPython. And also you don't have to pay for the entire overhead of the CircuitPython runtime. This is the example that I want to show today, so let's take it over to the bench and have a look. Finally, we've made it to the bench. Alright, let me show off my CircuitPython application. I've got an LED, I've got a button. I push the button, lights out, I let it go, lights on. Lights off, lights on. Alright, very underwhelming. I get it. I really actually thought that I was going to show you an interrupt-driven LED and light show with the Arduino and it was just going to blow your mind. But I saw it in real life and it just does not translate. Super boring, actually. But one thing I did notice while I was playing around is the unbearable overhead that is introduced by the CircuitPython runtime. Let me show you what I mean. Pay attention to that LED again. I'm going to push the reset button on the Swan and let's see what happens. Reset, lights out, let it go, and 1, 2, whoa! That's slow, guys. A microcontroller normally is like this. It's faster than that, actually, the way that it boots up. Let me show you that wasn't a mistake. Let me just do that one more time. All right, push the reset, lights out, let it go, talk a little bit, and wow, that's slow. All right, let's see what's happening just to make sure nothing crazy is going on. We'll flip to VS Code. Yep, that's the whole CircuitPython script. All it does is set up the digital I/O pins and then just sets the light to the state of the button. That's it, nothing else. So there is no big setup or anything slowing it down there. All right, so I have written an equivalent program in Arduino. This uses interrupts because that was supposed to be the big show, but fundamentally that makes no difference as far as it goes whenever you're looking at lights. But let me go ahead and compile this, and while I'm doing that, I'm going to explain what I'm about to show you. So right now I'm creating an equivalent Arduino binary. It does the same logic, we'll think of it that way. And then I'm going to use our Notecard CLI. This can be found in its GitHub repository, and it has a special utility called BinPack. BinPack will wrap up a binary produced by, I don't know, the Arduino IDE, and put some safety rails around it. This allows us to upload it to Notehub, and then whenever it goes out to different MCUs, it makes sure that there's a match between the two, and just make sure that you're not going to brick a device in the field. Okay, so we already created that, and now let me go ahead and use our Notecard CLI to pack that binary into a BinPack. Okay, that was it. There we go. And now I'm going to go over to Notehub. This is my brand new Bluestoberfest project that I created just for today. And this is the only device in it, which is the one that you saw sitting on my bench. I'll go to the Firmware tab. Surprise, there is no firmware created yet because I just did it, and I need to upload it. So I click the Upload button. I choose my file. It's going to be in Development, Arduino, Bluestoberfest, and it's the BinPack file. I'm going to choose that BinPack. Alright, I've got it selected, I save it, which uploads it, and it's already there. Like I said, these are super small binaries, so they go around really quick. Alright, so now that that's on my project, I go back to the Devices tab, because basically I could send that same binary out to as many devices as I want. I'll send it to all of them, which is just this one. So let me open up that device, and then I'll go to the Host Firmware tab. In here, I see I've got a Update Host Firmware button. I am offered a list of all the binaries I have uploaded, which is a list of 1. I'm going to select that, and I will say, yes, I want to update to this. And now it's going to go ahead and start working while I'm talking right now. So if you had a bigger binary, you can hit refresh, and you'll see that there's some percentage of it going through. And I'm going to flip over to my bench so we can see what's happening over there. Alright, you can already see that the note card's going wild, blinking, because it's already consuming that binary from Notehub. I'm also going to point out that there are no additional wires attached. I've got an antenna, a button, a battery, a note card, and a Swan. There is no way to upload new firmware to this except for with Outboard DFU. Okay, so while it's doing that, and you can see that the light's gone out, so it's halted the firmware for the moment so that it can kick on the new stuff. I did make one change so that there's another way that you can see that it's actually running new firmware, besides the fact that it's going to boot up in a lightning fast manner. Whenever I push the button now, the light will come on, and when I let it go, the light will turn out, except for in this first one, just so I make the light come on so you can see how fast this thing boots. Alright, so just to prove it's new stuff, I'm going to push down, nothing's going to change. There it is, I let go, it's going to turn off. Alright, so now it's opposite of what we saw before. Genius level stuff here. But, like I said, the real kicker is right here. I'm going to push this reset button, and then I'm going to let go now. Oh, there it is. That was so fast, I think it got on before I said the word now. Let's try that one more time to make sure. Push that reset button, it goes out, and let go, and oh, there it was already on. So, as you can see, the ability to use Outboard DFU to do more than just change your Python script or your same programming paradigm, just to stay inside of there, there's only so much I'm going to be able to tweak my Python script to make it go faster. Sometimes you have to switch away from that and switch in a whole new paradigm, and that's where we can take something like Arduino and just lay it down over the top of what we had there and then get that amazing benefit of just going lightning fast, or some dramatic change that you can only get with a brand new style. But anyways, guys, thanks for joining me today. Happy Bluestoberfest from me and little me over here. Turn that off. And I'm going to kick this over to Rob now, and he's going to tell you a lot more about Notehub and its features. But I'm glad you joined me. Happy Bluestoberfest.
Thanks, Zach. And yes, hi everyone. My name is Rob Lauer, and I'm Director of Developer Relations here at Blues. And I'm here to talk about some recent updates to the Notecard's firmware and its accompanying API, as well as improvements to Notehub, which, as Brandon mentioned earlier, is the Blues wireless cloud service that is really critical to securely routing your data to the cloud. Now, starting with the Notecard, and this isn't really new, but a common misconception we see is that people think there's just one Notecard. And as you can see here, however, there are actually 5 distinct Notecards, 4 cellular and 1 for Wi-Fi. Now, the 4 cellular Notecards are differentiated by protocols, LTE-M and NB-IoT for our narrowband Notecards, and LTE Cat1 for our wideband Notecards. They also work either globally in one of 139 plus countries or are region specific. So there's a Notecard for every need, and the API is identical for each, of course. Now, the first thing I really want to talk about with the Notecard is our firmware updates. Now, if you check out dev.blues.io, you'll see an extensive history of releases over the past year and more. And with a keen eye, you may notice that we started introducing LTS, or long-term support releases, in the mix. This is an important change for us and for you, as it provides versions of the Notecard firmware that you can trust will be supported indefinitely. So these LTS releases typically come out about a month or so after a major developer release. Now, what really interesting updates have we pushed with recent versions of the Notecard firmware? Well, there are certain, handful of random features that I wanted to highlight here as personal favorites. I'll explain these all in some detail in a moment, but first is payload fragmentation. Next is aux GPIO mode, and streaming accelerometer data, and then automatic alerts or notes when you lose USB power. So I want to look at these 4 really quickly. So with payload fragmentation, you can actually send much larger payloads, as in like binary files, to Notehub. So if you are sending a file, for instance, your host will need to disassemble that payload into fragments, usually about no larger than 8 kilobytes in general, and send them in successive web.post or web.put requests. Then Notehub is smart enough to know when the file upload segments are complete, so it can reassemble them in the cloud. Now, what got me pretty excited is this new host-free functionality introduced with aux GPIO mode. In a nutshell, you can use this API to send notes based on pin state changes. Now, with this type of request that you see here, the Notecard will automatically report any state changes on aux 1 through 4. As an example, I personally built a host-free power outage detector that's documented on our Hackster page at hackster.io/blues-wireless. We also have a leak detector tutorial there that uses a very similar mechanism. Now, you may know that the Notecard includes an onboard accelerometer. This is primarily used to wake and sleep the Notecard if any motion is detected when used in a tracking scenario, for instance. However, a common customer request has been to actually access that accelerometer data. You can do so now with the car.aux.serial request. This will stream data over serial with the XYZ positioning of the accelerometer at the cadence requested with that duration parameter in the request. Now, in the most recent firmware release, we've made my power outage detector even easier to create, and that's with an addition to the card.voltage API. By passing these additional parameters of USB true, alert true, and sync true, a note will be sent to Notehub as soon as a state change is detected on USB power. And I point all these out not to state that these API changes are earth-shattering, but rather you can see that we're trying to add as many new pieces of functionality that allow the Notecard to operate and perform real actions without a host microcontroller. And you'll see a lot more of this going forward. So those are some of my personal favorites, but some of you may be wondering how exactly you go about updating your existing Notecard's firmware, which is very much a valid question. The good news is there are two ways. You can update Notecard firmware manually using the STM32Cube programmer, or you can remotely update single note cards or entire fleets of note cards using the OTA DFU capabilities of Notehub. Note that this feature is different from the Outboard DFU feature mentioned earlier, as this pertains specifically to the Notecard firmware, not host firmware. So how do you update firmware manually? Well, as you can see by our extensive instructions here on dev.blues.io, there are some one-time hoops you have to jump through. However, once you get it set up, it does work like a charm, I assure you. But a lot of people find it much, much easier to just use Notehub. To use Notehub to update Notecard firmware, you simply click the Notecard firmware tab on the device you want to update. You click that big ol' update button, you choose the firmware version you want to deploy, and then you sit back and relax. And as the Notecard connects to Notehub, it will download the firmware and install it once the download is complete. This can certainly take some time depending on your connection and how frequently the Notecard is set up to connect to Notehub, of course. Now I want to pivot over to Notehub itself, and I want to talk a bit about our Notehub APIs. Now, this is really a feature I think provides a ton of value, as we provide programmatic access to virtually everything you can see in the Notehub web UI. So you can create inbound notes, you can view devices, you can edit device variables, all programmatically via command line or other service. Now recently we revamped the event API to better match the naming conventions used when routing data. We also have a brand new route API that lets you create and manage Notehub routes. So how are these APIs used and secured? Well, you just send curl requests or build the calls directly into any hosted service. In terms of security, today we're using a secure token that you manually create with this curl request as shown to the auth login endpoint. This request returns a session token, something we call a session token, that remains valid until you generate a new token. If you're not comfortable using a curl request in the terminal, you can also test these out with a tool like Postman just as easily. Now, as a quick example, you can retrieve information, for instance, on your Notecard devices with this API call to the devices endpoint. You just have to send that project UID in the URL and use your auth token as specified in the header. Likewise, to retrieve events from Notehub, you can use the events endpoint, and again, simply send the project UID and your session token. Now, all of the APIs, both for Notecard and for Notehub, are fully documented at dev.blues.io. But one thing I wanted to mention is that pulling events out of Notehub, like you see here, does consume 1 consumption credit per event. Well, what's a consumption credit, you ask? Well, the consumption credit is the foundation of our brand new pricing model for Notehub. Now, instead of paying a monthly fee, now you just pay for what you use. So if you are a light user of Notehub, you can use Notehub forever for free. That's because we provide 5,000 consumption credits every month. Or a better way of putting it is that we top you up to 5,000 every month. So that's 5,000 events routed out of Notehub per month for free. As an added bonus, each purchased note card gives you a one-time 5,000 consumption credits as well. So what actually uses a consumption credit? To be clear, anything you send to Notehub from a note card does not impact your credits. But just as mentioned, routing an event out of Notehub is 1 credit. Likewise, pulling an event out of Notehub via the event API that I just showed uses 1. Using one of the web APIs consumes 1 as well. Otherwise, every other Notehub API request counts as 0.001 consumption credit. So that's 1,000 API calls for 1 consumption credit. And remember, this is only Notehub API calls. There are, of course, no charges for sending API requests to the note card itself. Hopefully that's obvious, but just want to make sure. Finally, on this topic, I want to mention that you can purchase consumption credits in bulk at steep discounts. The pricing starts at $0.00075 per credit and only goes down from there. So that equates to 15,000 credits for $11. Cheaper than Netflix, right? Okay, last topic, and that is Notehub routes. Hopefully you know by now that we don't want to keep your data in Notehub. We're not trying to trap you into our ecosystem. We want you to route your data out to literally any cloud provider out there, whether it's AWS, Azure, Google Cloud, or an IoT optimized provider like a Datacake or an Ubidots. Really, from your host to your programming language to your cloud, the choices remain yours. Now, if you're not familiar with routes, they are just external APIs or server endpoints where events created by a device can be forwarded to. So they can target single devices or fleets of devices. You can just route the data that you want and even transform the JSON data on the fly with a language called JSONata. And of course, we have extensive routing tutorials available for you at dev.blues.io. But what happens when you are routing events and you see this dreaded icon appear? Well, it means that your route failed for some reason. Now, historically, this meant you're kind of out of luck, right? You had one chance to get your route right for this event, and it failed. End of story. What might have that failure have meant? Well, we define a route failure as Notehub being unable to connect to your remote endpoint, Notehub not seeing a response after 30 seconds, maybe Notehub received an invalid response from the endpoint, or any 500 level HTTP status code was returned. But all is not lost, because soon in Notehub you'll be able to automatically retry any failed routes. This will be an opt-in option when creating or editing your routes. Specifically, if a failure is detected, Notehub will attempt retries up to 3 times at ascending intervals of 5 seconds, 1 minute, and 5 minutes. And there'll also be a way soon of manually selecting failed events and retrying them. If you don't want this to happen automatically, for example, or even for when you're testing a failed route, I suppose. And to do this, you'll simply select the events you want to route. You'll choose the route or routes that you want to use. You'll see a status update as the event routing is retried. And also a brand new route log that is easier to understand with collapsible sections for each route, providing a lot more transparency and clarity in how your data is delivered and when. Now that's all coming very, very soon, but today actually you may not know that you can manually route a single event. Simply by navigating to the event detail screen, you can click the Route Event button and choose the route or routes you want to use for this particular event. Again, this is a great feature to use really, when you're in development or testing routing. So those are the big improvements to routing I wanted to talk about. Again, to summarize, today you can manually route a single event, but coming very soon, like as in today or tomorrow maybe, you'll be able to manually route multiple events. You'll be able to automatically retry failed event routes and take advantage of that revamped route log UI. Now, before we wrap up here, I want to take a moment to talk about a new contest we just launched with our friends at Edge Impulse. We call it Build a Smarter World, and the challenge is to build a connected IoT project that uses machine learning in some capacity, along, of course, with the Notecard to relay these results, or these machine learning inferences, as they're called, to the cloud. Now, we're giving out more than $5,000 in cash and other prizes, so if you are at all interested, just head to bit.ly/smarter-world-ml for all the details. The contest is open now. Submissions are taken until the end of December, so you have quite a bit of time. And with that, thank you all very much for attending. Before you leave, there are a few resources I wanted you to have. Please visit dev.blues.io for all of our technical resources we've been talking about today. Just for attending this webinar, we're offering 15% off any of our starter kits at bit.ly/Bluestoberfest. You can also scan that QR code for the same result. And just so you know, the discount doesn't appear until you get all the way to the checkout screen. And again, head to bit.ly/smarterworldml to learn more about our contest we're hosting with Edge Impulse. Well, thanks again for attending, and have a fantastic rest of your day.